So we have the function y equals e to the x. And we know that the limit as h goes to 0 of f of x plus h minus f of x over h is equal to f prime of x. It is the derivative. So we will take this function, f of x equals e to the x, and we'll find f of x plus h. That'll be e raised to the x plus h. Then we will subtract f of x from that, so we have e raised to the x plus h minus e to the x. And then the next step is to divide that by h. So we'd have e raised to the x plus h minus e to the x over h. Then we would find the limit as h goes to 0 of e to the x plus h minus e to the x over h. So now we have this thing set up and we need to do some algebraic manipulation on it. So one thing that we could do is recall that we would add exponents when we multiply with like bases. So in other words, e to the x times e to the h would be the same as e to the x plus h. Then we would subtract e to the x from that and then divide that by h. So the only thing we've done so far is take e to the x plus h and write it as e to the x times e to the h. Alright, now we can factor e to the x out of here, and we'll have e to the x times e to the h minus 1 over h. And we know that what's variable here is h. X is not variable at this point. So this e to the x can be brought out to the front. E to the x times the limit as h goes to 0 of e to the h minus 1 over h. This limit as h goes to 0 of e to the h minus 1 over h is equal to 1, and that is the definition of the number e. So therefore, e to the x times the limit as h goes to 0 of e to the h minus 1 over h is equal to e to the x times 1 is equal to e to the x. Therefore, when f of x is equal to e to the x, f prime of x is equal to e to the x. So this function is a derivative of itself, which just means then that its instantaneous rate of change is always equal to its function value at that point.